Section 13.4 Using equilibrium constants. The value of K sub C can be large or small. The size of the equilibrium constant depends on whether equilibrium is reached with more products than reactants or more reactants than products. However, the size of the equilibrium constant does not affect how fast equilibrium is reached. Equilibrium with large K sub C. When the reaction has a large equilibrium constant, it means that the forward reaction produced a large amount of product when equilibrium was reached. Then the equilibrium mixture contains mostly products, which makes the concentrations of the products in the numerator higher than the concentration of the reactants in the denominator. Thus, at equilibrium, this reaction has a large K sub C. Consider the reaction of sulfur dioxide and oxygen, which has a large K sub C. At equilibrium, the reaction mixture contains mostly products and a few reactants. See Figure 13.8. In the reaction of sulfur dioxide and oxygen, the equilibrium mixture contains mostly products, SO3, which results in a large K sub C. Equilibrium with small K sub C. When the reaction has a small equilibrium constant, the equilibrium mixture contains a high concentration of reactants and a low concentration of products. Then the equilibrium expression has a small number in the numerator and a large number in the denominator. Thus, at equilibrium, the reaction has a small K sub C. Consider the reaction for the formation of nitrogen oxide from nitrogen and oxygen, which has a small K sub C. Figure 13.9. The equilibrium mixture contains a very small amount of product, nitrogen oxide, and a large amount of the reactants nitrogen and oxygen, which results in a small K sub C. A few reactions have equilibrium constants close to 1, which means that they have about equal concentrations of reactions and products. Moderate amounts of reactants have been converted to products upon reaching equilibrium. Figure 13.10. At equilibrium, a reaction with a large K sub C contains mostly products, whereas a reaction with a small contains mostly reactants. Table 13.3 lists some equilibrium constants and the extent of their reaction. Two times 10 to the 11 is mostly products. 1.1 times 10 to the 7, mostly products. 1.6 times 10 to the negative 2, mostly products. 1.2 times 10 to the negative 2, mostly reactants. 2 times 10 to the negative 9, mostly reactants. Calculating concentrations of equilibrium. When we know the numerical value of the equilibrium constant and all the equilibrium concentrations except one, we can calculate the unknown concentration as shown in sample 13.6.